The second video we're going to talk about with estimation is filling the classroom. In this section, we're dealing with making logical assumptions. Assumptions about whichever place you're at, whichever thing you're trying to fill, that are relevant to the topic and realistic. It's hard to really explain, but when your students start talking about making assumptions, when you're trying to fill your classroom up with tennis balls, with anything, they'll make assumptions that don't really make sense, that aren't very realistic, or they don't really apply to the problem. So you want to make assumptions. Assumptions as simple as an empty classroom. If the classroom is empty, that's going to help making the whole tennis ball filling the classroom problem easier, because you don't have to take into account the volume or the space occupied by desks and furniture. Also, it's not necessarily realistic to imagine everything is perfectly square or rectangular, but whenever you're trying to calculate volume, well, that's another assumption that you can make, that the room is rectangular. I say it's not very realistic, but an item being rectangular is realistic. Okay? So several different things. Most tennis balls, if you talk about filling the classroom with tennis balls, most tennis balls have a range of size. So the tennis balls are all the same size. We're going to assume that to make the mathematics a little bit easier. And that's the major reason for making assumptions, is making the math easier. Concepts that you're going to cover are volume and volume of multiple objects, rectangular, prism, sphere, maybe cylinders, several different type of volume formulas you're going to need to know. You're going to want to make sure units agree, because when we talk about the volume of a tennis ball versus the volume of a classroom, you're talking about cubic feet for the classroom and maybe cubic inches or centimeters for the ball. So you're going to want to make sure your units agree, so unit conversions is going to be big. And then upper and lower bounds. How can we come up with an estimation of too many tennis balls for that classroom, and how can we come up with an estimation of not enough? And so that's what we're about to talk about here. So when we talk about our classroom, we have the height, the width, the length of the classroom, and there's a couple different ways that you can find the volume of that room and then divide into that the volume of the ball. Well, kind of to make sure we have too many tennis balls, is we take the volume of the room divided by the volume of the tennis ball. I like to call that finding liquid volume, because if you take volume of one object divided by volume of another, you're assuming there's no space. There's no air between the balls when they're resting on top of each other. It's 100% filled, like liquid conforms to whatever object you're pouring it into. So you have an upper bound by taking the volume of the room divided by the volume of the tennis ball. And then you also have this mathematical models that you can discuss with the kids. We have a cube, and that cube, the length of one side of that cube is the diameter of the tennis ball. So that takes into account the extra space on all the corners. That takes into account that extra space. And so we could find the volume of a cube that a tennis ball would fit into perfectly, and then divide that classroom by that volume of that cube. And then that would account for a lot of air. However, it wouldn't account for when the balls kind of settle between each other. So the balls are right beside each other, but it does not account for this scenario when the balls fall into the crevices and leave a little bit less air than what this model provides. So here, this is probably a method to do a lower bound. And then another method to do a lower bound would be how many tennis balls wide is the room times how many tennis balls high is the room times how many tennis balls long is the room. And again, it's going to be similar to this one, maybe slightly different, because you're not finding volume here. All you're using is the diameter and length. So you're taking 3 lengths multiplied together, which is volume. And so there's very, very many ways that you can calculate how many tennis balls might fit in a classroom. However, I want you to make sure that you don't just isolate yourself or restrict yourself to tennis balls in the classroom. I did things like a spree candy, which is a little bit of a cylindrical type of model. Everything, basketballs, footballs. You can do all kinds of different objects to fill in that classroom, and you're accomplishing the exact same teak, the exact same concept, trying to take mathematical models and estimate how much it would fit in a very, very large space.